Could we tune the telescope into universes being considered? And goodness, Mayal, who mentioned this? We're following down grandiose frameworks in lack of clarity ages. However, lengthy legitimate solicitation has dug into the starting points of our universe, and the prevalent explanation has been the hypothesis of the universe's starting point. Endless examinations and the helpful attempts of enormous quantities of specialists have upheld this theory, giving critical evidence for it. In any case, how the universe appeared, the location of science today is remarkably different from that of the past. Mechanical types of progress consistently present new theories and perspectives, testing what we once considered obvious experiences. In this developing legitimate scene, where new exposures reshape how we may interpret the universe, Neil deGrasse Tyson has turned into a recognizable voice. Now, a significant progression has been uncovered, as the James Webb Space Telescope has revealed a discovery that raises uncertainty about the deeply grounded hypothesis of the universe's starting point. This discovery includes the location of an astonishing 750 new universes, every one of which defeats our past assumption of what universes should resemble. By the manner in which the James Webb Space Telescope was thought of and expected to assist us with sorting out the start of inestimable frameworks, we should not be flabbergasted that it's driving us to scratch our heads. Join us as we examine how the new pictures from the JWST reveal the hypothesis of the ancient vast explosion. With the revelation of 750 new frameworks, specialists have progressed the hypothesis of ancient Big Bang as the fundamental explanation for the start of our colossal universe. According to this speculation, around 1 billion years ago, the universe showed up through a bizarre, pompous event or some likeness thereof. It's the authoritative birth story of the universe. The astounding thought of the photos gathered by the James Webb Space Telescope has tried analysts' cognizance of the universe's beginning stages. The hypothesis that these photos directly conflict with is the Big Bang hypothesis, which has for quite a while been regarded as a conspicuous truth by most cosmological researchers. These frameworks emit an impression of being too small, too smooth, too old, and too different when stood out from the eye of the Big Bang hypothesis. The small size of the observed frameworks thoroughly conflicts with the normal direct expansion of a developing universe, as demonstrated by the hypothesis. As the universe grows, things should appear larger with extending distance, according to the hypothesis of the universe's starting point. At the earliest reference point of the universe, all matter, energy, and the building blocks of the universe were packed into an extraordinarily small and concentrated point. This point is known as a singularity. Inside the singularity, all the matter and energy in the universe existed in a marvelously pressed structure. The ludicrous density induces that a gigantic proportion of mass and energy was concentrated inside an indistinctly small space. The temperature inside the singularity would outperform any temperature that can be seen or copied in our current perception of the universe. The energy stored within this hot, thick point was the seed from which the entire universe would spread out. Expansion, that is the explanation. The singularity marked the beginning of the universe as far as we know it. It was the starting point from which all that in our universe came. After the initial singularity, the universe began its journey of evolution and development. This cooperation occurred over the range of roughly 13.7 billion years, shaping the universe as we are concerned with it today. The expansion of the universe began with a surprising burst of rapid expansion known as inflation. During this stage, the universe extended at an unfathomable rate, far surpassing the speed of light. It's as if the surface of space itself was endlessly expanding, taking everything inside it. Curious to see what happens, inflation played a huge part in shaping the colossal scale structure of the universe. It smoothed out anomalies, homogenized the distribution of matter and energy, and set up for the subsequent development of vast frameworks, stars, and other enormous structures. As the universe continued to expand, the speed of development gradually slowed down. However, with this information, it's important to note that, although the initial phase of inflation ended, the universe kept on developing at a measurable rate. This continuous improvement is known as the expansion of the universe or cosmic inflation. Scientists have observed the effects of this expansion through various insights, like the redshift of light from faraway vast frameworks. The redshift shows that, as the universe expands, light waves get stretched and shift toward longer frequencies, moving them toward the red end of the spectrum. We'll dive into the nuances of this later on in the video. Every step of the way, look at the photos of the new frameworks that were taken by the JWST. They look completely shocking. Emphatically, you can see quite a large number of frameworks, all in a similar packaging, and the sheer power in the photos is something you can't ignore. That is what things look like to the common person. For investigators, things are the reverse. These photos are shocking, without a doubt. They don't match analysts' expectations. They're seeing an unexpectedly large number of astronomical frameworks, and these, as a matter of fact, are different in a couple of ways. They're smooth, more subtle in surprising ways than imagined, and really old. This huge number of wonders are causing quite a craze among the specialists. One paper even starts with the word alert in its title, so you know things are serious. The frameworks appear to be something they shouldn't. The period of the newly discovered infinite frameworks is by all appearances stunningly strange. Here, the JWST observations show the presence of universes that emit an impression of being surprisingly old. This challenges the typical course of events of vast framework formation and progression within the framework of the hypothesis of ancient Big Bang. Additionally, there's the fact that the abundance of newly observed vast frameworks is significantly higher than what the Big Bang hypothesis predicts. A specific course and thickness of enormous frameworks are expected by the Big Bang hypothesis, considering the expansion and progression of the universe. However, the JWST pictures show a massive number of universes, which raises questions about the accuracy of the predictions made by the hypothesis. There's also the fact that the structure of these vast frameworks is entirely unexpected. The hypothesis of the universe's starting point suggests that grandiose frameworks should show irregularity and variations in their designs due to the dynamics of their formation and evolution. However, the JWST pictures reveal universes that appear unusually smooth, lacking the expected level of complexity and roughness that one would expect, as demonstrated by the Big Bang nucleosynthesis hypothesis. While the expansion was going on, we fundamentally had all the stuff that makes up our universe fit into a small volume. Clearly, matter demonstrated incapable of managing in space like this, so something had to give as the universe expanded and cooled. Changes occurred. Particles like protons, neutrons, and electrons began to interact with light and energy in their surrounding environments. These interactions were a key part in shaping the development of matter in the universe during the first few minutes after the Big Bang. There was a process called nucleosynthesis. This process involved the creation of lightweight elements like hydrogen and helium. The temperatures and energy during this stage allowed for the fusion of protons and neutrons to form these fundamental atomic building blocks. Hydrogen, the most uncomplicated and abundant element in the universe, was formed primarily during this early period. Helium, the second most abundant element, also emerged during this time. These elements were instrumental in clearing the way for the formation of stars, frameworks, and other enormous structures that would come later in cosmic history. The combination of these basic elements was a significant accomplishment in the evolution of the universe. From a starting phase of a sea of particles and energy, the early universe transformed into a state where matter began to take form. This process laid the groundwork for the rich diversity of matter and the vast cosmic structures that eventually appeared. However, the James Webb Space Telescope challenged this picture. The systems observed by the telescope are remarkably small, smooth, and, importantly, very old, which tests the assumptions made by the theory of the ancient Big Bang. Instead of chaotic and messy vast frameworks, the photos reveal mostly smooth plates and efficient spiral designs, resembling the universe we see today. This astonishing observation challenges the idea that mergers are a normal process in the development of universes. These new universes appear not to have undergone the kinds of difficulties that would typically be expected if we were following the Big Bang theory. If there are few or no mergers happening out there, it becomes less likely for small universes to develop and turn into larger ones. This means that these universes were not originally formed as expected by the Big Bang theory. In conclusion, the James Webb Space Telescope has transformed how we may interpret vast framework development and progression. By challenging established hypotheses and revealing a wealth of new discoveries, the insights made by the JWST have raised important questions about the factors driving the morphology of vast frameworks, the timeline of their development, and the nature of cosmic evolution itself. As scientists continue to analyze these groundbreaking discoveries, we can expect further revelations that will reshape our understanding of the universe's origins and its evolution.